Okay, so we want you guys to really understand what's going on here, and understanding which pairs, which ordered pairs actually satisfy an inequality is part of the problem. So we have to see which ones work and which ones don't. Which ones make the equation true? Those are the ones that are solutions. Which one of these makes the inequality false? Those are the ones that are not solutions. So they give us some ordered pairs to kind of test out here. We're going to basically take these ordered pairs and substitute them into the inequality to see which ones are true, which ones are false, and that would basically tell us which ones are solutions and which ones are not. So I have everything set up over here. We're going to take a look. Here's all the ordered pairs that were given to us. We're going to see if these are true or not. So we're going to start off with the first one, 0, 1. All you had to do is take your inequality and substitute the x and the y for the 0 and the 1. Okay, so we substituted in here and in here. All right, time to start simplifying. 2 times 0 is 0, plus 6 times 1 is 6. So this is going to give us a final inequality that says 6 is less than 12. Is that true? So in this situation, we would say, yes, 6 is less than 12. So this is true. That means that this right here, the first ordered pair, 0, 1, is true. So over here, you would drag this one into the, let me drag it, into the true solutions category. Okay, then we look at 5, 0. So we'll come back over here. Let's look at 5, 0. Plug it in. 5, 0. Okay, 2 times 5 is 10, plus 6 times 0, that's 0. Okay, so we have 10 plus 0, that's just 10. Is 10 less than 12? Yes, this is also true. That means that this coordinate right here, 5, 0, satisfies the inequality, which means that this is another solution. So 5, 0, we would drag it here. And at this point, if you kind of understand what I'm doing, you can stop the video, try some of them on your own, and then come back and check to see if you got them correct. Okay, now that you're back, we're going to take a look at the rest of these and see what we come up with. So here we go. We're going to try the 9, negative 1. Plug it in down here. 9, negative 1. You got some negative numbers in here. Let's see how that plays out. 2 times 9 is 18. 6 times negative 1, that's negative 6. So we have 18 minus 6, that is 12. Is 12 less than 12? No, 12 is actually equal to 12. So this statement right here, this inequality is actually false, which means that this coordinate right here is not a solution to our inequality. So we would take the 9 and the negative 1 and bring them down here to the false category. Okay, let's keep looking at the rest of them. We have 3 more to look at. 3 and 2. I'm going to kind of go a little bit faster through these now. Okay, let's plug in the 3, plug in the 2. 2 times 3 is 6, plus 6 times 2 is 12. 6 plus 12 is 18, and 18 is not less than 12. So this right here is actually false also. Okay, this one is going to be false. Now, we can assume that these two will be true, but just in case we made a mistake over here, it's safe to just go ahead and check these anyways. So negative 4 and 2, let's go check that one next. Move myself over here. We're going to check negative 4 and 2. Plug those in. Okay, substitute them. 2 times negative 4 is negative 8 plus 12. Okay, negative 8 plus 12, that's going to be positive 4. Is positive 4 less than 12? This one would be true. Okay, so we would put that under the true category. And I'll let you guys check the last one. I'm going to go ahead and just test my luck, put it in there, and we'll see what we end up getting. Let me submit my answer. And it says those are correct. We found which x and y values, or ordered pairs, make the inequality true. Basically, that allows us to see which ones are solutions and which ones are not. So basically, remember, these still represent your candies and your combos that you can buy. So basically, it says you can buy 0 candies and 1 combo, and you would have some money left over. You can buy 5 candies and no combos, and you would have some money left over. Now, what about this? This is kind of weird. Like, how can you buy -4 candy boxes? Maybe some of those don't make sense in the context of the story, but they still satisfy the inequality, and we'll talk about that later. Okay? I'll see you guys in the next video.